So now so gamma naught is called the trace map of order 0. So our next theorem states that the range is not all of L2 of Rn minus 1. Okay, so the if V belongs to H1 of Rn plus, this implies that gamma naught V belongs to H half of Rn minus 1, and gamma naught from H1 to of Rn plus to H half of Rn minus 1 is continuous. Okay, so this is what we would like to show, and in fact later we will show, I won't prove it fully, but it is known that in fact this is a surjective map. Okay, that we will come to it at the end. Okay, so proof. Step 1. So let V belong to D of Rn. That's always our starting point, and you say W of x dash is V of x dash 0. Okay, so now we are going to, it's in L2 of Rn minus 1. Okay, therefore we can apply the Fourier transform to this. So let W tilde of xi dash be the Fourier transform in Rn minus 1 of W. So again xi I am going to write as xi dash xi dash in Rn minus 1. Okay, let V hat xi be the Fourier transform in Rn of V. Okay, so tilde usually I have been reserving for extension by 0, but now there is no confusion because we are working in all of Rn, and therefore extension does not arise. So I am using the symbol tilde for the Fourier transform in Rn minus 1. Okay, so we want to connect these two. What is the connection between these two things? Okay, by the Fourier inversion formula, V of x dash 0 is equal to integral e power 2 pi I x dot xi. Now x dot xi, xn is 0, xn is 0, so the xn part won't come, so I will just have x dash dot xi dash. Okay, since xn equal to 0. Okay, 2 pi I x dash xi dash into V hat xi d xi. Okay, and that, so this is integral over Rn, and that I will write as integral Rn minus 1 of e power 2 pi I x dash xi dash, because that's all that, and then integral minus infinity to infinity V hat xi d xi n d xi dash. Now apply the Fourier inversion formula in Rn minus 1. So this is nothing but W x dash, and that's equal to integral over Rn minus 1 e power 2 pi I x dash xi dash into W tilde xi dash d xi dash. Okay, so now W tilde and integral V hat d xi n all belong to S of Rn minus 1. This is a very easy thing to check, and therefore by uniqueness of Fourier inversion, we have that W tilde xi dash is nothing but integral minus infinity to infinity V hat xi d xi n. Okay, so that is the first step where we have related the two. So now we go to step 2. So what is the claim? We claim that it's in h half of Rn minus 1. So we want to show that to show W belongs to h half of Rn minus 1. Okay, so in other words, we need to show that is to show xi dash going to 1 plus mod xi dash square power half W tilde xi dash square integrable. Okay, so we just go ahead and try to compute that integral. So integral Rn minus 1 of 1 plus mod xi dash square power half mod W tilde xi dash square d xi dash, that's equal to integral over Rn minus 1 1 plus mod xi dash square power half into mod integral from minus infinity to infinity V hat xi d xi n square d xi dash, that's equal to integral over Rn minus 1 1 plus mod xi dash square power half into modulus integral minus infinity to infinity V hat xi into 1 plus mod xi square power half into 1 plus mod xi square power minus half d xi n square d xi dash. Now for the term inside the modulus, I will apply Cauchy-Schwarz inequality. So Cauchy-Schwarz this is less than equal to integral over Rn minus 1 1 plus mod xi dash square power half into integral minus infinity to infinity mod V hat xi square into 1 plus mod xi square d xi dash d xi n into integral 1 plus mod xi square power minus 1 d xi n minus infinity to infinity into d xi dash. So the power half which should have come is taken up by the square here, and therefore we have this. So now let us look at this integral minus infinity to infinity d xi n by 1 plus mod xi square. This is equal to integral minus infinity to infinity d xi n by 1 plus mod xi dash square plus mod xi n square. So this is like the form a square plus x square in the denominator, that is 1 by a tan inverse x by a, and then you have 2 times 0 to infinity. So that is equal to 2 times pi by 2 into 1 plus mod xi square xi dash square power minus half. Okay, so if you substitute that here, that will give you, so 2 into this got cancelled, so there will be a pi. 1 plus mod xi square to the minus xi dash square to the minus half will cancel with 1 plus mod xi square to the xi dash square to the 1 half, so that gets cancelled, and then you have just this integral here d xi n and the d xi dash, and therefore you get integral of Rn of plus Rn, sorry, mod V hat psi square into 1 plus mod psi square dx dz. Oh, that's not here. Pi times integral over Rn of mod V hat psi square into 1 plus mod psi square dz. And what is that? That is nothing but pi into norm V square 1 Rn. So this implies that W belongs to h half of Rn minus 1. Okay, and you have norm W in half Rn minus 1 is less than or equal to pi times norm V in 1 Rn, and this is for V in d of Rn. So now if you take V in h1 of Rn plus, then by reflection extend to h1 of Rn. Okay. Now if you extend it to h1 of Rn, then you know d of Rn is dense there, so you take Vn in d of Rn, Vn converging to V in h1 of Rn. Then by what we have just seen, we saw that if you take Wn minus Wm in half Rn minus 1, this is less than or equal to pi times norm Vn minus Vm in 1 Rn, and therefore this implies that Wn is Cauchy in h half Rn minus 1. So Wn converges to some W in h half Rn minus 1. But Vn also converges to V in h1 of Rn plus, and that implies that gamma naught Vn converges to gamma naught V in L2 of Rn minus 1. But gamma naught Vn is nothing but Wn, and that goes to some W, and therefore this implies that W equal to gamma naught V, and this implies that gamma naught V belongs to h half Rn minus 1. Also you have that norm gamma naught V in h half Rn minus 1, okay, is less than or equal to pi times norm V gamma naught Vn, we have this 1 Rn, and therefore norm gamma naught V half Rn minus 1 is less than or equal to pi times norm V 1 Rn, but V is nothing but the reflection thing, so that is a prolongation operator, so that is less than C times norm V in 1 Rn plus, and therefore you have that the map gamma naught from h1 of Rn plus to h half of Rn minus 1 is continuous. So in fact we can show that gamma naught is surjective. that is range of gamma naught equals h half of Rn minus 1. I am not going to prove this. You can check the proof in the book Topics in Functional Analysis and Applications, which I mentioned to you, and you have that. In fact, you can actually construct a pre-image for this one. Okay, so now remarks. So with very minor modifications in the computations above, we can show that gamma naught maps Hm of Rn plus to Hm minus half Rn minus 1. So it's very easy to show this. Okay. Also, if U belongs to D of Rn, we can show minus du by dxn belongs to L2 of Rn minus 1, and in that, in fact, it lies in h half Rn minus 1, and that this extends as a continuous linear map gamma 1 from H2 Rn plus to h half Rn minus 1. More generally, we have a sequence of maps gamma j such that gamma equals gamma naught gamma m minus 1 for such that for any m positive integer maps Hm of Rn plus to product j equals 0 to m minus 1 of h m minus j minus half of Rn minus 1. Okay, so all this can be done. There is just modifications of the calculations which we have been doing. Our next aim is to look at the kernel of this trace maps gamma, and we will see that subsequently.